thank you, and thank you for the invitation to take part to this symposium. I have been asked to address the quality of carbohydrate in a physiological perspective. Here are my disclosures. And before talking about quality, let's remind you very quickly about the definition and classification of carbohydrate. So carbohydrates are formed from one to a large number of OSIS molecules, and sugars are generally mono and DO, so mono and disaccharides. Larger polymers are starch and maltodextrins. The function of these sugars and starch in the body is essentially energy production and energy storage. It is also used for the building of macromolecules such as nucleic acid or for glycosylation of protein. But one point which is important is that this class of compound is not essential as nutrients. I mean, they can be synthesized endogenously. Now, as part of carbohydrate, there are also other polymers of OSIs which are not digestible by the human digestive enzymes, and that's what we call dietary fibers. And the function of these dietary fibers in the body is essentially a prebiotic function. It's important for gut health. And it is also considered to contribute to energy production through the generation of short-chain fatty acids. Now, when you talk about quality, quality is not really a concept which is familiar to biologists. It's more a concept for economists. And one of the criteria of quality is that it is a product that meets the customer's needs. In terms of carbohydrate for the body, that would be a product which produces energy. And the second criteria is it has freedom from defects, so it is safe. Here, for dietary carbohydrate, that would be the absence of deleterious effects. So start that, one may have quality of carbohydrate from the way they provide energy to the cells, how efficient they are in providing energy, and that involves variation in gut digestion and absorption, and cells, and by the absence of adverse effects. And here, of course, we could cover a lot of adverse effects. I focused on the main effects related to non-communicable diseases. That is the prevention of obesity, so that the carbohydrate does not lead to an excess energy intake, and the fact that it does not increase known risk factors for diabetes, cardiovascular diseases, non-alcoholic fatty liver disease, and so on. Now, very quickly, you have on the left represented sugars, and sugars are present in our food as free glucose, free fructose, but also a little bit as, but also and mainly, excuse me, as sucrose and lactose, which are dimers of monosaccharides. And these disaccharides are split into monosaccharides and then absorbed in the bloodstream. So they will be absorbed as glucose, galactose, and fructose. Regarding starch, that's polymers of glucose, and starch will be entirely absorbed as glucose. So the effect of glucose are very close to the effect of starch in a physiological perspective, while the effect of sugar, there is in addition the effect of fructose and galactose. Regarding the intestinal absorption of sugars, glucose and galactose are absorbed through co-transport with sodium, which is energy dependent. It relies on the action of NAK8 ATPase, and that allows the complete absorption of glucose against its glucose and galactose against its gradient of concentration. Regarding fructose, fructose is absorbed through a facilitated transporter here, which is GLUT5, and as such, it relies on it requires the presence of a concentration gradient, which means that the absorption will not be complete, and there is always some part of fructose which remains unabsorbed. So, compared to glucose and galactose, fructose is less readily absorbed. Now, once in the bloodstream, the glucose, galactose, and fructose will be metabolized by the cells. The most straightforward way to metabolize monosaccharides is with glucose, and glucose can escape hepatic uptake, go directly to the peripheral cells, and be efficiently used as an energy substrate. Part of it will transit through glycogen with a little loss of energy. But as a result, the energy made available to cells, it's between 95 and 100%. That will be our reference point. If you compare galactose, galactose will be metabolized in the liver in galactose 1-phosphate, and then be transferred to glucose 1-phosphate, so it will join the glycogen cycle. Most of the fructose will be released as lactate, and 100% of the energy content of fructose will be transferred to cells. Part will be converted into glucose, and that comes through gluconeogenesis with a relatively large energy cost. So 90% of the energy will be released to cells when fructose uses this pathway. Now, when you have high fructose intake and a low energy output, part of the fructose will go to de novo lipogenesis, so it will synthesize fatty acids, and that has a low energy efficiency. So here is for the energy efficiency of these sugars. Now let's look at the second criterion, which is the absence of adverse effects. So I won't go into the review of all metabolic effects of fructose. And just remind you that fructose is known to be lipogenic, and that high fructose diet is associated with an increase in blood triglyceride concentration that you see on the left part of this slide. You see that it is a dose-dependent increase in fasting and postprandial blood triglyceride concentration, which may represent a cardiovascular risk factor. Of interest, this is specifically an effect of fructose. It is observed with hypercaloric high fructose diet. It is also observed with an isocaloric high fructose diet, so in the absence of excess energy intake, while it is not observed to the same extent with an excess energy as fat. There is also, in the same line, an increase in intrahepatic fat content in response to a high fructose diet. Here again, that is dose dependent, and that's observed with very high amount of fructose in the diet. And finally, there is indirect evidence that fructose exerts less satiating effect than carbohydrate-containing, glucose-containing carbohydrate, since it elicits a lesser release of postprandial leptin, and it produces lesser suppression of ghrelin. And these two factors are to contribute to the increase in energy intake. Now, these potential deleterious effects of fructose have been known for a long time and have been largely described in the literature. Very little is known about the effect of galactose. And one recent study shows here that a high galactose diet or an acute increase in galactose increases postprandial blood triglyceride much more than glucose. And as a matter of fact, the effect of galactose on blood triglyceride is the same than that of fructose. So that's a new observation, and that raises the question of possible adverse effect of galactose. Now, if we stop here briefly to summarize, if you try to assess the carbohydrate quality according to energy available to body cells, energy made available to body cells, glucose and starch would be on the top. Galactose would be somewhat lower, about 95%, and fructose would be lower, about 90% when it's converted first into glucose, and about 70 to 80% when it's converted to fatty acids. And lactose, which is a dimer of glucose and galactose, between lactose and sucrose, in between glucose and fruit. Now, if you look at the absence of adverse effect on glucose and lipid homeostasis, compared to starch and glucose, which would be here our reference point, fructose clearly has more potential adverse effect. Sucrose intermediate, because it's a mix of glucose and fructose. And there are very little information, but the first information we have about galactose, they also have adverse effect regarding at least lipid homeostasis. Okay, now let's switch to the second part of this presentation, is that until now we have been talking about carbohydrate based on their chemical nature. But we eat food, and the epidemiological evidence indicates that the risk of non-communicable diseases varies a lot according to the type of foods concerned. So if you look at the different sources of sugar, fruits contain, of course, sugars, but a high amount of fruits in the diet is associated with a low risk of non-communicable disease. Similarly, dairy products contain sugars, but the risk of non-communicable disease is not increased by dairy product consumption and may even be a little bit reduced. On the other hand, if you focus on sugar-sweetened beverages, these are clearly associated with an increase in non-communicable disease. So all these contain the same, or at least fruits and sugar-sweetened beverages contain the same sugars, glucose, fructose, and sucrose, that have different effects on health-related outcomes. And that may be due to other constituents of the food, such as dietary fibers, vitamins, polyphenols, and so on. If you look at complex carbohydrate, here again, there is a lot of variation. And what appears from the epidemiological studies is that whole grain products are associated with a low risk or low risk of non-communicable disease compared to refined carbohydrate. So what can be the possible explanation for that? There are many explanations, and I won't go into details. I will just mention the major candidates. The first is type of starch present in the cereal, the glycemic index, glycemic load associated with a particular food, its dietary content, and finally, I will not elaborate about that, but for every food that may be also related to other dietary constituents like polyphenols, minerals, and antioxidants, or even other macronutrients such as protein. If you look at the type of starch, the starch is present in natural product in a variety of forms. And one can partition it into digestible starch. And digestible starch is starch granules which can be attained by digestive enzymes. So it's polymers of glucose. It's composed of amylose and amylopectin. It swells upon cooking, and the swelling facilitates the work of digestive enzymes. And based on in vitro digestion, you can identify a rapidly digestible starch, which is usually well swelled, and slowly digestible starch. Now, in cereals, another part of the starch is in the forms which is very difficult to digest or non-digestible, and that's what is called resistant starch. And there are various types, and that is found in whole grain, in raw starch granules, or in cooked and then cooled starch. And finally, some of these resistant starch are produced by the industry and added to the foods. Now, you see here just a few examples of foods, and you see that the amount of rapidly and slowly digestible starch depends on the processing of the food. So the amount of rapidly digestible starch is relatively low in uncooked flour, but it will increase when the flour is cooked as bread. And that it depends on the type of processing. And also that for beans, for instance, cooking and then cooling the starch will increase the amount of resistant starch. So many factors contributing to introduce a variability in starch digestibility. Now, the second factor which may play a role is the glycemic index, and that's not independent on starch digestibility. So some carbohydrates will elicit a rapid increase in glycemia, followed generally by a rapid glycemia and possibly a late postprandial hypoglycemia or relative hypoglycemia, while other with a high glycemic index will have a delayed but sustained glycemic response. There is concern that the high glycemic index foods may favor cardiometabolic disease, and there are two major mechanisms proposed. One is that during this initial phase, there is an hyperinsulinemia, which favors anabolism, including the storage of fatty acid in adipose tissue, and the development of hypertriglyceridemia. And that's the absence of a prolonged hypoglycemia may stimulate early food intake. So the third mechanism I would like to mention is the presence of dietary fat within the food. The co-ingestion of carbohydrate and fat will have several digestive and metabolic effects. First, the presence of dietary fat will slow the gastrointestinal time. Some of this fiber will act as a gel in the gut and delay glucose absorption, and that will delay a little bit the peak of glucose after ingestion. In addition, dietary fat will be fermented in the large bowel, and that will generate short-chain fatty acids. Short-chain fatty acids have beneficial effect for gut enterocytes. That's their major beneficial effect. But they may also play a role in stimulating the release of satiating hormone like PYY and GLP-1, or exert direct metabolic effect on the adipocytes to decrease fat storage. And finally, of course, dietary fat are prebiotic to beneficial gut bacteria. So if we come back to our summary and now try to address the quality of carbohydrate according to safety issues and absence of oh, I'll start again this one, sorry, because I don't see the... Okay, now if we come back to the summary of the quality of carbohydrate, when you classify carbohydrate according to the food class and use the criteria of energy efficiency, sugar-sweetened beverages will be the most efficient. Whole grain would certainly be the less efficient because they contain relatively large amount of resistant starch, and refined cereals and whole fruits would be somewhere between. Now, if you look at the relationship with health-related outcomes and with risk factors for non-communicable disease, then clearly whole fruits and whole grains have beneficial effect. Sugar-sweetened beverages are at the other end of the spectrum. And I must say that in between, there are a variety of food for which we don't, or I would not know how to actually assess the quality in the physiological perspective. So we come here to the summary of this presentation. If we have to provide a physiological ranking of the quality of carbohydrate, if we look at the perspective of energy efficiency, glucose and digestible starch will be the most efficient, followed by galactose, and then resistant starch and fructose. If you look at the as a criteria at the association with risk factors, then glucose and starch would be the reference, and fructose clearly is more deleterious. There are many unknowns on that, and for instance, galactose. I just showed you that the recent findings show possible adverse effects of galactose, but we need to have more information about this sugar. And I would like to remind you that not only the amount of sugar, but the amount of energy intake, and energy intake as the sugar is an important factor. According to epidemiological links between food groups intake and health, I won't learn you anything when I will tell you that whole grain fresh fruits clearly have beneficial effects, and that there is much concern that sugar-sweetened beverages may have adverse effects. That may be due to the differences in the type of starch, glycemic index, and fiber content of these foods, and possibly also to the presence of other nutrients. And in between, there are many carbohydrate-containing foods, and the quality regarding their health-related risk remains to be assessed. And I am at the end of this presentation. I would like to thank you for your attention.